For our summary today, I actually want to do one of the explore problems, but then also wrap it up with uh, reversing this process. So one of a major topic today is multiplying. So we'll practice this, and if you notice in this particular problem, there's three terms multiplied by three terms. So I need that area model to be the case. So my 3x squared and x and -1 is going to get multiplied by x to the fourth, by -2x or -2x, and then +1. Again, you don't need the plus there, but sometimes it's nice to know that that's positive. And then we just multiply. So we have 3x squared by x to the fourth is 3, and there's 2 powers at being multiplied by 4 powers, so now we have 6 powers. So 3x to the sixth. 4 powers multiplied by 1 power is x to the fifth, and then -1x to the fourth. Again, you don't have to have the 1 there, but I'm just going to put that just for memory. -2x times 3x squared is -6x to the third. -2x times x is -2x squared. -2x times -1 is positive 2x. Again, don't need the positive, but if you want it there, you can. And 1 times anything is itself, so this whole row is just going to be itself. So 3x squared times 1, x times 1, -1 times 1. And now we just look for those like terms. There's only one sixth degree or sixth powered term, so there it is. There's only a 1/5 degree term, so x to the fifth, there it is. Some people like to kind of slash these off as they go, just for so they don't forget anything. There's 1x to the fourth term, so there it is. There's 1x to the third term, so there's that one. There's 2x squared terms, 3x squared minus 2x squared, or 3x squared plus -2x squared is 1x squared. There are 2x terms, so 2x plus 1x is 3x, and then -1. So there's our big idea behind multiplying polynomials, and that's a big concept for our class. But the follow-up, the summary, is doing a little bit of both. Is multiplying, but also kind of recognizing what can be unmultiplied. Remember, it's called factoring. So there are times where I'm not going to use an area model. In this particular one, this is one of them. This is something that I can just do very quickly, just using kind of standard distribution. So 2x times 5 is 10x squared. 2x squared times 3x would be 6, and then x times x squared, x to the third. Just generally, we always write that in standard form, remember? So I'm going to write that higher powered term first, the lower powered term or the lower degree term second. So that's one way of doing it. Remember, you can also just set up an area model if that's what you choose to do. Totally fine with that. It works great. But now let's think about undistributing. It's called factoring. So I'll just do a couple examples, and then you can keep trying. Now remember, this is a concept we'll revisit. So every time we revisit something, you're going to get better at it. So think about, this would be the completed area model, and I've got to think what could this have been that would have multiplied to both terms to get a 6a and a 14a squared. Well, I know there's an a, and I know there's also at least has to be a 2. It couldn't be a 6 because 6 doesn't go nicely into 14, and it couldn't be a 3. 3 doesn't go nicely, but a 2 goes nicely into both. And then I know that this term has to be 3. 2 times 3 is 6, and then I can check it by multiplying. And same thing, I know that this has to be 7 and at least one more power of a. So this would be an example of factoring, and my final answer comes out to be 2a times 3 plus 7a. And we just factored for the first time. And we can take a look at a couple more examples. But remember, this is just distributive property. It's two going into one form or out of the same form. So we can practice all kinds of examples. So same deal. I'm going to look for common terms in each of these 3 terms now. So my area model is going to include 3 terms. And the one kind of standing out at you should be 2. And looking at all my powers, every term has at least 4 powers of x. So I'm going to factor out x to the fourth. And this one I'm going to go right to left here. So if I divide out the 2, all of these are going to be 1s. And if I divide out 4 powers, I got to think how many are left. So 10 divide out 4, I now have 6 terms left. 5 powers dividing out 4 gives me 1 power. And if I divide everything out, all I'm left with is that 1. So my final answer is going to be 2x to the fourth, which is what I factored out. And what's left is 1x. I'm just going to write that as x, and then 1x to the sixth. And we'll do one more. We're doing well on time. And just looking at, okay, one last one. So we have 6z squared and negative 15z. So what can be divided out of both of those terms? I know for sure a z, because there's two powers here, and there's one power there. And then what's the largest thing that can be divided out of both a 6 and a 15? Well, that number is 3. So what does that leave us left with? Dividing the 3 out leaves us with a 2 and a negative 5. Dividing a z out of the 15z leaves us with no more z's left. And then if I divide out a z from z squared, I have z. So I get my final factored form, 2z minus 5. And you can do that for just about any expression. So we're looking at, some people call it undistributing, some people call it all kinds of things. We're going to call it factoring.